In this very tutorial, we want to look at what we call independent and then dependent events. Independent and then dependent events. If you are new on this very channel, kindly hit on the subscribe button for me. So let's start with the independent event. What is it? Two events are said to be independent if the occurrence of the outcome in the first event doesn't have any influence or does not affect the probability of the outcome of the second event. Then we are saying that these two events are independent events. So let's take it that we have two events, event A and then event B. And then event B, event A contains the outcomes 1, 2. That is the outcome from the toss of a die. And then let's event B be the outcome from the toss of a coin. So we have head and then tail. So what we are saying is that these two events are independent events if the occurrence of the outcome from the first event, let's say 3, does not affect the probability of the outcome in the second event, let's say head. And we know that when we have a die and then a coin, when we toss them together or when we toss them one after the other, the occurrence of the outcome from the toss of the die does not affect the probability of the occurrence of the outcome from the toss of the coin. So we can say that these two events are independent events. Another example of an independent event is the roll of a die 2 times or the toss of a coin 2 times. So when we toss a coin 2 times, we have tossing the coin 2 times. On the first toss of this coin, the outcome from this does not affect the probability of the outcome of the second toss. So we can say that tossing a coin 2 times is an independent event. Now, how do we find the probability of an independent event? We can do that by looking at this diagram on the board. So let's consider this diagram. We have our universal set A and then set B. We can see that set A and then set B are disjoint sets. They have nothing in common, right? Good. If they ask us to find A union B, we want to find a set of what? A union B. What do you do? Now, when they ask us to find A union B, it means we have to put the element in set A and then set B together. So you can write it as A plus B, right? Which is the same as the element in A, which is mx, and then we have the element in set B, which is what? Yw. So we can say that our A union B will be given as what? M, X, Y, and then W. That is A union B. So in probability, when they ask us to find the probability of A union B occurring, which is written as the probability of A union B occurring, which is the same as probability of A or B occurring, is to add the probabilities of these two individual events together. So we are going to have the probability of A plus the probability of B. So for independent events, to find the probability of A union B, which is the same as probability of A or B, all what we have to do is to add the probabilities of the individual events together and then you are good to go. Now, what if they ask you to find the probability of A and B if the two events are independent events? So we have probability of A and B, which is the same as probability of A intersection B. All what we have to do is to find the product of the individual events together. Is to find the product of the probabilities of the individual events together. So we have probability of A multiplied by probability of B. Therefore, if event A and then event B are two independent events, then the probability of A and B, which is the same as probability of A intersection B, is obtained by multiplying the probability of A by the probability of event B, and then you are good to go. So this is how we find the probability of an independent event. Now let's move on to what we call dependent events. When we talk about dependent event, as the name implies, depends. It means one of the events depends on the other. So, and two events are said to be dependent events if the occurrence of the outcome of the first event has influence or can affect the probability of the outcome of the second event, then we can say that these two events are dependent events. The first outcome from the first event has influence on the occurrence of the outcome of the second event, and then vice versa. Example of dependent event is drawing a marble from a box without replacement. So let's take it that we have a box or a bag which contains marble, let's say 10 marbles, of which 5 are green and then 5 are red. And we want to pick 2 marbles from this bag, one after the other. We are picking 2 marbles from this bag, one after the other. So on the first pick, let's take it that we picked this marble without replacement. We pick it without replacing it back. So it means that within the bag, we are having how many marbles? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means that the number of balls in the bag has been reduced by 1. So on the second pick, since this marble was not replaced back, this marble is going to affect the occurrence of the outcome of the second pick, because the total number of marbles in the bag had been reduced by 1 instead of what, 10 in all. So this marble which was not replaced back will affect the chances or the occurrence of the outcome from the second pick of the marble from the bag. So we can see that picking a marble from a box or a bag without replacement is a dependent event. So how do we find the probability of dependent event? Let's consider the diagram on the board. So in finding the probability of dependent events, let's consider this diagram on the board. So we have our set A, set B, and these two sets are intersecting. So we have an intersection. Now if they ask us to find A union B, now A union B means you have to put the elements in set A and then set B together. So set A, we have plus B. Set A, we have the elements X and Z. So we have X and Z. And then we have set B, we have Z and then what, Y. So we have X, Z, Z, and then Y. So you can see that one of the elements or the members is repeating, and that is Z. So you have to do away with one of them. And how do you do away with it? You can do away with it by subtracting one of the elements from it, so that we can have something of this therefore. So we are going to have X, Z, Y, and then minus what? Z. Now this Z is what? The intersection of the two events. So we have our A intersection B. So we can say that A union B is obtained by adding the two events together. So we have A plus B minus what? A intersection B. So therefore, if we are to find the probability of A union B, probability of A union B from a dependent event, then we are going to have probability of A plus the probability of B minus the probability of A intersection B. So this is how we find the probability of a dependent event. Now to find the probability of, let's say, A intersection B from a dependent event, all what we have to do is to find their individual probabilities and then we multiply them together. So this is how we find the probability from a dependent event. If A and B are two dependent events, then the probability of A union B is given as this, and then the probability of A intersection B is also given as that. Very, very easy and then simple. Let's look at some few examples on independent and then dependent events, and then we say bye-bye to this topic. So we want to look at this example. Two events A and B are independent events if the probability of A occurring is 5/12 and the probability of B occurring is 3 out of 10. We want to find the probability of A union B and then II probability of A intersection B. So we are saying that event A and then event B are two independent events. So to find the probability of A union B, since the event A and B are independent, we are just going to add their individual probabilities together. Probability of A, we have 5/12 plus probability of B, we have 3/what? Over 10. So when you do your addition, you are going to get 43/60. Very, very easy and then simple. So let's look at this. Probability of A intersection what? B. Since event A and event B are two independent events, then the probability of A and B occurring is to just multiply their individual probabilities together. So we are going to have P of A, we have 5/12 multiplied by what? 3/10, and that's giving us what? 15/120, and then when you simplify, you are getting 1 out of 8. So therefore, the probability of A and B occurring is 1 out of 8. Very, very easy and then simple. So let's look at this one. We have X and Y are two independent events such that P of X is 3/7 and then P of X intersection Y is 2/5. We want to find P of Y, P of X union Y, if X and Y are not independent events. So let's start with the first one. We are having P of Y, P of Y. So we are saying that X and Y are two independent events. They are what? Two independent events. And then we are being given P of X intersection Y. And then we are also being given P of what? X. Since these two events are independent events, then the probability of X intersection Y is obtained by multiplying the probability of X by the probability of Y. So you can say the probability of X intersection Y is obtained by multiplying probability of X by probability of what? Y. So probability of X intersection Y, we have 2/5. P of X, we have 3/7. multiplied by P of y. So you can say that P of y is equal to 2 over 5 divided by 3 over 7, which is the same as 2 over 5 multiplied by 7 all over 3. And that's giving us 14 all over 15. Therefore, the probability of y is 14 out of 15. Now let's look at I. So we are saying that P of x union y, we want to find it if x and y are not independent. So it means that with the I, we are saying that x and y are dependent. If they are dependent, we should find the probability of x union y. So if they are dependent, then the probability of x union y is giving us probability of x plus probability of y minus probability of x intersection y if they are dependent events. P of x, we have 3 over 7. P of y, we have 14 all over 15 minus P of x intersection y, we have 2 over 5. So when you do your addition and subtraction, you are going to get 101 all over 105. Very, very easy as ABC. Let's look at one more example and then we move. So let's look at this example. Noah plays a game of table tennis on Saturday and a game of badminton on Sunday. The different outcomes are represented in the tree diagram below. So this is the probabilities for the table tennis and then badminton. So with the table tennis on Saturday, we have 0.4 probability of winning and then 0.6 probability of losing. And then with badminton, the probability that he wins is 0.7 and the probability that he loses is 0.3. So with the same side, the probability that he wins badminton is 0.7 and then probability that he wins but lose badminton is 0.3. We want to find the probability that Noah wins both games. Noah wins both games. So we have the TT and then badminton. So from the question, we can see that the two events, the table tennis and badminton, are two independent events. The occurrence of the outcome from the play of the table tennis does not have any influence on the occurrence from the play of the badminton. So these two events are two independent events. So to find the probability that Noah wins both games, so we are going to use TT for table tennis and then B for badminton. So we have probability that he wins both games, which is the same as probability of the table tennis intersection what the badminton. And we can write this probability that he wins the table tennis multiplied by the probability of winning the badminton. So we just have to plug in their respective probabilities. So winning the table tennis, we have 0.4. Winning the badminton, we have 0.7. So when you do your multiplication, you are going to get 0.28. So the probability that Noah wins both games, that's probability that he wins table tennis and badminton, is 0.0. Very, very easy and as easy as that. This brings us to the end of today's lesson. See you tomorrow. Bye bye.